Okay, so now let's shift over to objective number 2, really learning about the purposes and how we calculate central tendency measures. So when you think about this phrase, measures of central tendency, what's the middle tendency, right? What do we tend to do? So really when we think about central tendency measures, this is the most typical, what's the most common, what's the most likely value or values in a data set, right? Think about central tendency as an average, and we use the word average as a very broad term that really makes up these central tendency measures, which we're going to learn about, which are mean, median, and the mode. And you may have heard these and learned about these in previous classes, and if it is, great, this is going to be a good review for you. And really, the best measure of central tendency really depends upon the characteristics of a variable. And what do you think I mean by the characteristics of a variable? Levels of measurement. So again, make sure you know levels of measurement so that we know how do we then choose and appropriately use these central tendency measures, mean, median, and mode. So just a nice overview, and we're going to go into more detail about how we calculate these, but just a nice simple overview. Calculating the mean, we add up all the values divided by the total number of values. The median gives us the middle value, and we talk about the middle value or the midpoint of all of our data when they're organized from low to high. And the mode, what's our most common value? Which one do we see happening the most? Here are some examples you can take a look at. Okay, measures of central tendency. When do we use them? So if you recall, I mentioned depending upon the level of measurement for any given variable, it'll tell us whether or not we can calculate and report the mode, the median, or the mean. And this table here is a nice breakdown of what level of measurement we have for any given variable and what are the appropriate central tendency measures that we can report for that type of variable. So as you can see, when we have nominal variables, all we can do is report the mode. And we'll see that the mode is simply the most frequently answered response. And as we move up the level of measurement chain, from nominal up to ungrouped interval ratio variables, we can see that we can do more and more with these central tendency measures for the higher levels of measurement. So we have grouped ordinal variables. We can calculate the mode and find the median. And I'll get to what this asterisk is in just a moment. But notice that when we have full-ranked ordinal variables, we can't do anything with that. And we'll see why that is. And then now we have our grouped interval ratio variables and ungrouped interval ratio variables. Now notice how I've lumped those two into one category, interval and ratio variables. Why is that? Well, if you recall, we have nominal and ordinal variables, which we classify as qualitative variables, which means they're really just looking at categories or groups, and that the corresponding numbers to these categories or groups have no real numerical value. Conversely, when we're looking at interval and ratio variables, these variables that have numerical values actually mean those actual numbers. So now interval and ratio variables are clumped simply because they are considered quantitative variables. But again, as we talked about at the end of last week's material, we can have grouped or ungrouped interval ratio variables, where grouped is simply what is your income, 0 to 100,000, or what is your age, 18 to 24, 25 to 30. Whereas ungrouped is simply what is your income, and you give me a number, or what is your age, and you give me a number. And so as we can see, when we have ungrouped interval ratio variables, we can actually report the mean, median, and the mode. But when we have grouped interval ratio variables, even though they are quantitative, we can only report the mode and the median because we're working with groups now. So notice again that as our levels of measurement increase in terms of hierarchy, we can use more measures of central tendency. But I want to bring the point back to this asterisk here. When we have grouped ordinal variables, we can calculate a mean, and this is a very controversial statement that I'm making here. But in my class, it would be appropriate for you to calculate a mean for a grouped ordinal variable if that particular variable has 5 or more responses, or 5 or more groups in the possible responses, and if we can make sense of that mean. So can we interpret a mean of whatever it is for that particular grouped ordinal variable? If it doesn't make sense, then we can't and we shouldn't calculate and report the mean. But if it does make sense and we can interpret it in some meaningful way, then we can go ahead and calculate and report the mean for a grouped ordinal variable. And we'll see that in the coming slides. Okay, so let's start with the simplest measure of central tendency, the mode. So simply the most frequently observed score for a variable. And it can be calculated for all variables. If you notice in the previous slide, we can use the mode for any and all levels of measurement. Okay, so let's say you're a shoe salesman. It wouldn't make sense, and you wouldn't be interested in knowing what the average shoe size or what the middle observation shoe size of the shoes he sells. He'd want to know what is the most common one, right? Which shoe size, a 6 in these pumps, sells the most. So I want to make sure that I get a size 6 and I order those more and more and more. But he's not going to want to know, oh, he sells, 6.75 shoe size, which is the average. Because first of all, there isn't a 6.75 shoe size. And really, that's not really going to really meet the demand of the most frequently shoe size, which is a 6. So in this case, if you're a shoe salesman, you'd be interested in the mode of the shoe size you sell the most. So if we're looking at a frequency table, how would you figure out what the mode is? Okay, think about the definition of the mode. Looking at this frequency table, which company rank is the most common? Well, we see senior manager is the most common, right? With 18 people, which happen to be the biggest percent, 25.7%. In the frequency table, this is really just the answer with the highest frequency or largest valid percent. And if we're looking at a bar chart, which one's the mode? We have favorite cereal, cornflakes, Cheerios, Life, and Kix. Well, simply, it's the tallest bar. We see 6 people out of all the people that answered said that Life was their favorite cereal. So here are different ways that you can find the mode in a frequency table or in a bar chart. And really just simply put, if you're given a list of scores, count them all up, and find the answer that occurs most frequently. In this case, cats. Most pets in the house. Some other things about the mode. It is possible to have no mode. So for example here, we have values from 1 to 10. We see that every single value between 1 and 10 had a frequency of 10. So in this case, because they all have the same frequency, there is no one answer that is most common. So there is no mode. It would not be appropriate to say that all of them are the mode, because there isn't one that occurs most frequently. We can also have more than one mode. So here we have scores. Again, just thinking about a bar chart, we're really going to be looking at the height of the bars to tell us which responses or answers are the most frequent. And in this case, we have 2 of them that are exactly the same frequency at a frequency of 9, a score of 5 and a score of 15. So in this case, we have 2 modes, and we would call this bimodal. Okay, let's move on to our second central tendency measure, which is the median. And this is really the value of the middle observation in a data set when we put them in order from lowest to highest. Okay, remember when we think about central tendency, so far the mode is talking about the most frequent. The median is talking about where is the middle one. Out of all of these numbers, which one is the middle position? We can find the median for all variables really except for nominal variables. So how do we find it in the frequency table? Well, we're really going to be looking at a cumulative percent of 50, or any answer that passes that 50th percentile. If we have a list of scores, we need to first put them from lowest to highest, And then we find the middle observation by using this midpoint formula, which is total sample size plus 1 divided by 2. And this will give us our midpoint position. Couple caveats when we're doing the median and we're listing our scores to find the middle observation. If you have an even number of observations, you'll end up having 2 numbers in the middle. So what we'll have to do is take the average of these 2 middle numbers to get your median. If you have an odd number of observations, when you figure out your midpoint position, it's simply going to be that position, that number, that very middle position. So we'll see some examples when we work through these calculations. So here, looking at it in a frequency table, we want to look for the answer that has the cumulative percent of 50 or higher. So if we take a look, we have shoe size from 6 up to 10.5. And we see that 6.7% of people had a shoe size of 6. We see 20% of people have a shoe size of 6.5 and smaller. We see 40% of people have a shoe size of 7 or smaller. And we see that 53.3% of people have a shoe size of 7.5 or smaller. So again, we want to look for the answer that contains the 50th percentile. Well, if we look at our shoe size of 7, that only makes up 40% of our sample, those who have a shoe size of 7 or smaller. So that does not include the 50th percentile. We have not crossed that threshold yet. But if we're looking at 7.5 shoe size, we see that the cumulative percent is 50.3%. So that means that the 50th percentile falls within 7.5 shoe size because we've passed the 50th percentile. In fact, 53.3% of our total valid sample, to be exact, 53.3% of our total valid sample have a shoe size of 7.5. So in this case, our median is 7.5. Notice when we refer to the median, we're actually talking about the actual response, which in this case is 7.5. We do not say that the median is 53.3. That's just the percentile that corresponds to the median. Again, if we have an odd number of numbers, we have in this case 5 numbers, middle observation is going to be the actual number itself. But if you have an even set of numbers, in this case we have 6, notice the middle position is between 4 and 5. We then have to get the average of 4 and 5 to get our median, which in this case is 4.5. And our last central tendency measure, the mean. By definition, this is the mathematical average. And really the way that we do this is we just add up all of our scores and divide it by total sample size. That's how we calculate it. But if you think about it conceptually, it's the sum of all the distances of cases from the mean is 0. So if we add up the distance from all of the cases from the mean, so we'll have the mean, and we take each number and we subtract it from the mean. If we add all those up, it'll equal 0. Also, the sum of these squared distances is smaller than the sum of the squared distances from any other value. So there's no way that if we had any other number, that if we were to square the distances from each individual case from the mean, there's no way any number is going to be smaller than these numbers. So these are just some characteristics of the mean itself. But calculating it, simply we're taking each individual score, adding them up, and dividing it by the total sample size, total number of participants in the sample. And really, we use this more so for ungrouped interval and ratio variables, with that slight caveat of taking a look at the table of when we can use the mean for given exceptions. Alright, so here's an example of calculating the mean. Let's say you're trying to figure out what was your GPA last semester. Well, let's say you took 5 classes. And in each class, you can calculate what your GPA is. And so in your 5 classes, you earned 4.0, 2.0, a 3.7, 3.33, and a 3.0. So the average, to calculate this, we're simply just going to add them all up and then divide by our total sample size, which in this case is 5. We have 5 classes. Notice that I have brackets or parentheses around the numerator. Because we're typing this out, or we're seeing this written this way, we must use parentheses to notate order of operations. If you're familiar with the acronym PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, we must tell ourselves what mathematical operations do we do first, second, third, so on and so forth. So in this case, we must use parentheses or brackets to indicate that we add up all of our scores first, and then we divide that sum by 5. Otherwise, if we didn't put these brackets or parentheses around here, we would do 3 divided by 5, get that number, and then add them all up, which would not be appropriate. So now that we've set up our equation, simply work through it. 16 divided by 5 gives you a 3.2 GPA for your overall semester of 5 classes. Examples of wrong use of measures of central tendency. So when do we not use the mean, median, or mode for a given situation? Here we have a table of descriptive statistics. We have gender as our row and as our variable. And we see in the second column we have N, our total sample size. We had 101 people answer gender. Well, we know gender to be what? What are the possible responses? Male or female, right? And let's say that we assigned males to be 1 and females to be 2. Completely arbitrary, right? We know that 1 doesn't really technically mean 1 or males, and 2 doesn't mean that females are twice as much as males. But look it, we calculated the mean out of these 101 people, as well as the standard deviation, which we'll learn about in the next chapter. But let's just focus on this mean and our sample size. Does it make sense for us to say that the average gender is 1.43? Does that make sense, knowing that 1 means male and 2 means female? How would we interpret this 1.43 average gender? We can't, right? It doesn't make sense. So we shouldn't calculate the mean for nominal variables. But we also shouldn't calculate the median for gender either, right? Again, another nominal variable. But what we should do is we should create a frequency table, because a frequency table will show us the count, the sample size for each response, male or female. So in this case, we see male, we had 43 males, females, we had 58 females. In this case, this makes much more sense, right? And we can actually see that there were 3 individuals who did not answer this gender variable. So again, out of the 101 individuals who answered this gender variable, the 1.43 does not mean anything. We cannot interpret a mean for gender, which is a nominal variable. What we can interpret is a frequency table which gives us frequencies, percents, and valid percents. So this would be a wrong use of calculating the mean and even the median for nominal variables. Here's another example. What is your yearly household income? Sample size 102 people, mean 2.32. So how would you interpret that average household income? Does that mean that the yearly household income was $2.32? That doesn't make sense, right? What's really happening here? Well, we shouldn't calculate the mean for grouped interval or ratio data either. So really what we ended up seeing for this type of example was, what's your yearly household income? And we see that the possible responses were 0 to 24,999, 25,000 to just under 50,000, 50,000 to just under 75,000, and 75,000 and plus. We can then say that, 0 to 24,999 was assigned a 1, 25,000 to 49,999 was assigned a 2, 50,000 was assigned a 3, and 75,000 plus was assigned a 4. Well, in this case, we can somewhat make sense of a mean. But again, if we just look at this 2.32 mean, it makes no sense at all as far as how we interpret the variable of household income. By looking at a frequency table, we can then say, yes, it makes sense, and we can say that the mode household income is $25,000 to $49,999. And even then, we can even say that that mode, that household income bracket, is also the median household income, which is what you'll see most of the time when you hear in the newspaper or in the media or in some reports about the median household income or the median housing price. So hopefully you see how it's appropriate to use the mean. In these two instances, it's not appropriate, but we would use the mode and the median. What about ordinal variables? So it does make sense to calculate the mean for grouped ordinal variables, depending on the coding of the responses, though. Again, some more caveats, some exceptions. So here's an example. If I asked you a pain level between 0 to 10, where 0 was no pain at all and 10 was excruciating pain, and I gave you the paper and you had you fill it out, and you said, okay, out of 25 people, the average pain score was 5.44. So after giving them the pre-test, I went ahead and gave them all Vicodin. Then I asked them 6 hours later, what's your pain score now? From the same scale of 0 to 10. The same 25 people averaged 5.16 on the pain scale of 0 to 10, where 0 is no pain and 10 is excruciating pain. Can we interpret these mean pain scores before and after taking Vicodin? We can, right? We can say that this is pretty moderate pain from 0 to 10. It's pretty much right there in the middle. In addition to that, we can even see and compare the pre and post, the before and after pain scores, and we can see that the Vicodin indeed reduced the pain on average by about 0.3 of a point, right? It went down from 5.44 down to 5.16. So there was a slight decrease in pain. So in this case, pain, which is an ordinal variable, scale from 0 to 10, we can make sense and we can calculate and report the mean. However, look at this ordinal variable. What is your yearly household income? Again, it doesn't make sense for us, again, to report these types of statistics, the mean, when using grouped ordinal variables or grouped interval or ratio variables. Here's an example of full ranked ordinal variables. Again, this is where only one person or one case can fill one ranking. It doesn't make sense for us to report what the average ranking is, because what does that mean? That we don't have average rankings. We have, are you ranked first, ranked second, ranked third? What's your position? So for full ranked ordinal variables, we don't report the mean or the mode or even the median. Full ranked ordinal variables don't really make sense for us to report central tendency measures because there are no central tendency measures. It all is what it is. Each person or case has their own ranking. So when we're talking about ungrouped interval ratio variables, what's better, the mean or the median? Well, whenever possible, we want to kind of report the mean. It's preferred, and you'll see this in most research that you'll read anytime we talk about medication and certain weight or certain height. It's all really talking about the mean. What's the average? And it's very commonly reported. And it's actually pretty easy to calculate. But when it's not appropriate to use the mean is when we have some extreme scores. Extreme scores which we call outliers. And sometimes there's someone who is just really an outlier. They scored really, really high on the SATs, or they scored really, really low on the SATs, or there was a team that just really outscored their entire division. Somehow, some way, you have these anomalies. You have these outliers. Sometimes it's because of data entry. Sometimes instead of reporting an age of 9, or change it, or you can type in 999, or type in 99, especially if you're working with just a study on adolescence. Instead of putting 99, you'd be like, whoa, where did this old person come in, right? That would be an outlier if it was a true, but it could also be data entry error. So we had to make sure that we look at our data, make sure that it's clean, for one thing, but also we also want to make sure, is this outlier a real outlier? And if it is the case, then we want to make sure we keep them in there, but then report the appropriate central tendency measure, which in this case, the mean would not be appropriate. So here's an example, hopefully that'll illustrate the mean and the median when we have an outlier. Here is Wilt Chamberlain. You may know who he is. He's a legend Harlem Globetrotter. But one of the things that he was known for was he was very, very promiscuous. In fact, it's reported that he had anywhere from 10 to 20,000 lifetime sexual partners. 10 to 20,000 sexual partners in his lifetime. That's crazy. So let's say, for example, I want to do a study involving lifetime sexual partners, and it just so happened that Wilt Chamberlain was in my data set. So I had 10 people, my 11th person was Wilt Chamberlain. So let's see how Wilt Chamberlain affects the mean and the median given his outstanding 20,000 sexual partners, which is a pretty crazy and outrageous outlier. So here's a data set. I have the 11 individuals. We see one first person said they had one sexual partner in their lifetime. One person was still a virgin. 4, 8, 12, 30 sexual partners. And there's good old Wilt Chamberlain with 20,000 sexual partners. I want you to go ahead, take some time, and calculate the mean with the 11 individuals, and then the mean without Wilt, which means we have 10 individuals. When you think you've got your answer and you've worked through them, go ahead and continue on with this video. Otherwise, pause the video now to calculate these two. Okay, so hopefully you calculated the mean with and without Wilt Chamberlain. Let's see if you did it right. So in our first step, we're simply going to add up all the participants, and we get a total of 20,075. We divide that by our total sample size, which in this case was 11 individuals, to give us 1,825 lifetime sexual partners on average for these 11 individuals. Think about that for a second. If you were that one virgin out of the group of 11 people, and you read a study that said, oh, on average, of these 11 people, average sexual lifetime partner was 1,825. You'd be like, no, I'm a virgin still. I do not have that many sexual partners. So let's look what happens when we calculate it without Wilt Chamberlain. Obviously, we're going to take out his 20,000. We only get 75 sexual partners as a sum of all these now 10 individuals, right? Because we took out Wilt Chamberlain, our sample size is now not 11, but changes to 10. And when we then do the math, we then see that our average lifetime sexual partners among these 10 individuals was 7.5. Now look at these two numbers, 1825 and 7.5. Which one seems to be more realistic of really what this sample looks like? Hopefully you said the 7.5 sexual partners, right? If you just look at, we have a range from 0 to 30 people. And then we have Wilt Chamberlain, who's way out there. 7.5 lifetime sexual partners seems pretty reflective of these 10 individuals. But with Wilt Chamberlain, we can see 1,825, that mean has been completely skewed, has been completely thrown off. Now let's look at the median. Using Wilt Chamberlain, calculate the median. Go ahead and spend some time, pause the video. When you've worked through it, continue on with the video. Okay, so if you've worked through this, first thing you want to do is what? Put them in order. So we put them in order from lowest to highest, and then we calculate our midpoint. Our total sample size, in this case we have 11 individuals, right, because we see Wilt Chamberlain is in here. 11 plus 1 divided by 2 gives us 6. That 6 is not your median. That 6 is your midpoint position to give you the median. So now that we've identified the midpoint position, we count from each end to that middle. 1, 2, 3, 4, 5, 6. So in this case, the midpoint fell right on one value. That one value is now our median. So 5 is the median. So think about this. Comparing our median and our mode, we see with Chamberlain we have a median of 5. When we calculated the mean with Will Chamberlain, we had 1,825. Those two central tendency measures do not jive up. But when we had Will Chamberlain median 5 and Will Chamberlain with our mean 7.5, those two things, they're in the same ballpark, right? So hopefully you can start seeing how the mean can be skewed and be really thrown off when we have outliers. What about our mode? What's the mode? Go ahead and work through this and see if we can figure it out. Pause the video, come back. All right, easy thing to do. Since we already calculated the median and we put them in order, use that. And really all we're looking for is the most common response. And we see we have 5 and we have 8. Both of them show up twice. So in this case, the mode is 5 and 8. We have a bimodal distribution. So think about this now. Taking all 3 central tendency measures, we identified our mode to be 5 and 8. We identified our median to be 5. And we identified mean to be 7.5 without wilt, but really 1,825 with wilt. And the mode and the median also had wilt. So again, really just comparing all of these, hopefully you can see how the mean is very sensitive to outliers. But the mode and the median are not sensitive. Notice they still give us a really good idea of what the central tendency measure is, given that Will Chamberlain was in this data set. Okay, here's a final example of calculating the mean, median, and mode. Go ahead and take some time working through these. When you're done, go ahead and continue on with the video. Otherwise, pause the video now. Okay, hopefully you work through these problems. The median, 5.2. The mode, 9.6. And the mean, add them all up, 6.03. I will say that one thing you want to make sure that you include that we do not see here are the parentheses for the numerator in the median and in the mean. Make sure you add parentheses around these formulas. Hopefully you got these right answers. Last thing, rounding. If my answer is not a whole number, what decimal should I round my answer to? Well, here we go. For this class, round one digit to the right compared to the original numbers that are given to you. So if I give you an example or a problem that says, find the mean of 6, 7, and 9. I've given you whole numbers, so your answer should be 7.3. Another example, if I give you numbers 3.0, 3.7, 4.0, your final answer should be 3.57. Remember, when it comes to rounding, if your last number 0 to 4, it means you round down. 5 to 9, it means you round up. Here are some examples. Alright, so summarizing. Frequency tables contain possible answers or responses to the variable. It gives you your frequency count for each possible answer, the percentages, the valid percent, and the cumulative percent. And we know how to calculate each one of them, talking about total sample size, total valid sample size. Our 3 central tendency measures, mean, median, and mode, and we use them really based upon the level of measurement. We really don't want to use the median or the mean when we have nominal variables, and really we can use the mean for ungrouped interval ratio variables unless we have outliers. In this case, we do not want to use the mean, we want to use the median and the mode.